So you might get asked about the VIE, or the vacuum insulated evaporator, in your FRCA exam, so we'll go through it. Now if you want to store oxygen, you can store it as a gas in a cylinder, but you have to have it at quite high pressure if you want a meaningful amount of gas to be contained within your cylinder. Most cylinders are stored at 13,700 kilopascals, which is 137 atmospheres of pressure when they're full. And even at this enormous pressure, you're only looking at a few hundred litres of oxygen contained in your cylinder. So we're trying to find a better way to store lots of oxygen for your hospital, because you could have a manifold of hundreds of cylinders, but that's not an efficient way to store it. So instead, when we're storing huge amounts of oxygen for the hospital as a whole, for their wall supply, we store it as a liquid. And the reason we store it as a liquid is each litre of liquid oxygen will evaporate to give you 800 litres of gaseous oxygen. So it's a much more efficient way to store the oxygen. So it sits in this VIE, which is essentially a giant thermos flask. And you've got the liquid oxygen, and above it you've got the gaseous or vapor phase oxygen that is evaporated off the top. And it is sealed inside this huge thermos flask. And this is stored at minus 150 degrees Celsius and around 10 atmospheres of pressure. And what's really cool is this system doesn't need any active cooling to keep it at minus 150 degrees Celsius, because it does it all itself. It's so well insulated that once it's cold, it doesn't warm up very quickly. Then what happens is, as you use the oxygen that is stored in the VIE by giving patients oxygen in the hospital, you drain off that vapor to give to the patient, which encourages more to evaporate. And because evaporation is an endothermic process, when this liquid evaporates into the vapor form, it takes heat energy out and cools it down further. So the more you use it, the cooler it gets. So we say it uses the latent heat of vaporization to stay cold. Now 10 atmospheres of pressure is the amount of pressure required to keep this liquid oxygen in its liquid form. Say that this is the pressure exerted inside this chamber by the vapor molecules. So the 10 atmospheres is the saturated vapor pressure, the pressure exerted on the walls of the container by the vapor above the liquid at minus 150 degrees. Saturated vapor pressure we've talked about in other videos, but as you increase temperature, the molecules have more energy, they exert more pressure on the side of the container, so saturated vapor pressure will increase with temperature. So this is a happy medium of cold enough that the saturated vapor pressure isn't unmanageably high, but not so cold that it's ridiculously difficult to keep it at that temperature. Now, we can't use a pressure gauge to measure how much stuff is left in here, because what happens is, as you use the oxygen, the vapor gets replaced by more liquid evaporating, and it will stay at that saturated vapor pressure until all the liquid has run out, and then you just have vapor left, and then it will start to drop the pressure inside. So instead, the VIE sits on a set of scales, and you can weigh it to work out how much oxygen is left inside your tank. So you might be thinking, what if I'm using loads and loads of oxygen and I'm evaporating lots and lots off? It's going to get colder and colder as the latent heat of vaporization drags more energy out of the liquid. So as it gets colder inside, then the saturated vapor pressure is going to decrease. So the pressure inside the VIE is going to decrease, and therefore the pressure delivered to the patients is going to decrease. So this could be a problem. So the VIE has safety mechanisms built in, and one of these is called the evaporator. This is a very simple mechanism. Essentially, it's exposed tubing, which when the pressure in here gets too low, because it is too cold, it simply lets some of the liquid go through these pipes that are exposed to the outside. The liquid oxygen will warm up, it'll evaporate, turn into the vapor phase, and restore that pressure back inside. Likewise, if it gets too warm inside because not enough oxygen is being used and not enough is evaporating off and cooling it down, and the pressure inside is building up, there are pressure release valves that will stop the pressure getting too high, and they will simply allow some of the vapor to boil off into the air, and that will allow the temperature inside to drop back down again. So you've got two simple mechanisms for maintaining a constant temperature and pressure inside. So this is an entirely passive mechanism. It doesn't need any electronic input to keep it functioning. And it's a very efficient way to store lots of oxygen, because 1 litre of liquid oxygen is 840 litres of gas